Cybersecurity is the department of no.
Welcome everyone to the Industrial Security Podcast. My name is Nate Nelson. I'm here as usual with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of our show today. Andrew, how are you?
I'm very well, thank you, Nate. Our guest today is Wally Magda. Wally is a senior standards instructor. He's an advisor. He's a former NERC CIP auditor, so he's seen sort of NERC CIP from the other side, from the audit side. He's going to be talking to us about mistakes that people are making in return on investment calculations for, cybersecurity investments, how we're getting the question wrong. And so, of course, the answer doesn't come out terribly well either.
Okay, then let's get into your interview with Wally.
Hello, Wally, and welcome to the podcast. Before we get started, can I ask you to, tell our listeners a little bit about yourself and about the good work you've been doing in the industrial security space?
Sure, Andrew. Greetings. Thanks for inviting me to your podcast. My security experience started off in military nuclear missile command control systems. And then I got into intelligence agencies and eventually landed up in corporate enterprise security. But I did start out in electric, gas, water, wastewater utility. Many years ago, as an instrumentation and control field tech. And then I progressed on to managing control systems as a process control engineer. And seeing the need for security professionals out in the corporate world with operations technology, I stepped into the enterprise level security realm. And I've been working with critical infrastructure sectors such as energy, chemical, water, wastewater, and the defense industrial bases. That is all fascinating to me. I'm learning something new all the time. It just keeps me going. Eventually, I struck out on my own, forming Wally.biz LLC as a one-man band business. I'm an independent contractor, and I'm involved with numerous cyber and physical security assessments and training for critical infrastructure sectors across the globe. In the last few years, I have focused more on the cyber and physical security standards such as the 62443's NIST and NERC CIP. My passion lies in the knowledge that I've gained from the hands-on experience traveling the globe. I never stop learning. Every engagement has unique characteristics. And I've learned that there isn't a cookie-cutter control system, even if it's a skid-mounted chemical system made by the same vendor deployed in different plants.
And our topic is, ROI, return on investment errors in the field of industrial security. I mean, this sounds bad. What is it that we're talking about here?
So you've already defined ROI as return on investment, and it could mean a lot of other things like risk of incarceration. The cybersecurity arena has many facets to it. It's kind of hard to just pick out the ROI and just focus on that, but we'll try to do that here because we have the small mom and pops to large conglomerate asset owners. It's the full gamut. Then we have our vendors, our supply chains. They've got to play in this. They have the same challenges, and they may not have the revenue flow that their asset owners have. Cost is a factor. It's a fact of life. You and I, when we go shopping, we look for the best value for the best price. It's not that much different in the control system world. But when it gets to security, the secure products are more expensive versus the less expensive stuff on the programmable logic controllers.
I agree in principle. I mean, I shop for groceries too, but we're talking industrial security. Can you give me an example? What kind of decisions, what kind of trade-offs are we looking at here?
Well, what we're looking at, from what I hear in my travels from the product suppliers, the companies that produce this, if an asset owner can purchase a PLC or programmable logic controller with minimum security features of $1,000 and it does the same job, and then the one with the security features is $5,000, $5,000. What are you going to lean toward? And you look at the cost. So what do I want to spend on security? There isn't anything such as 100% security. I know that, but it's a risk assessment decision. Does the benefit of security outweigh the cost and risks? How do I prove that I haven't had a breach? And how often will it occur? How do you prove a negative that a hack hasn't occurred because I paid the $5,000 for that more security. And another challenge with that is if I buy that higher security, I need to now have the care and feeding included into the cost over the years. Who's going to take care of that device? Who's going to keep the upgrades on it? And I have more things on my plate than security. I got money and people and time and a whole bunch of other departments that I have limited resources to work with.
Andrew, 1,000 versus 5,000 for a refinery, does it really matter?
In the example of a refinery, if we're talking upgrading the PLCs, we're not talking one PLC. In a refinery, you certainly have 100 of these things. You might have 500. You might have 1,000 PLCs. If you got 1,000 PLCs, that's sort of easy to do the math. We're not talking $1,000 versus $5,000. We're talking $1 million versus $5 million. It's a difference of $4 million here.
Okay, but still, a refinery produces huge volumes of products every single day. So, I mean, you're right, $4 million. But again, does it really matter?
It varies by industry, but a lot of heavy industry, refining, power generation, you name it, is producing a commodity. A commodity is where, the stuff that's produced is pretty much identical across the entire industry. Every site produces the same thing. It's the same electricity. It's the same gasoline, provided the quality specifications are the same. It's the same stuff. And a truism of capitalist theory is that, in an international market, the international market is pretty much capitalist. Within a nation, there might be, price constraints and whatnot, but internationally, gasoline, oil, commodities trade, they're sold at a price that approaches the cost of production. In a competitive market, the price of a commodity approaches the cost of production, which means profit margins are razor thin. When your cost of production and your price are almost the same, it's razor thin. To your example, refineries have to buy their oil at market price. They sell their gasoline at market price, or their diesel fuel, or their whatever. And the gap between what they sell and what they buy is their gross margin. And out of that have to come all of their operating costs, all of their interest expenses on the loans that they took out, the $1 billion loan to produce the refinery. Profit margins are razor thin. And so, a couple of $1 million could put a material dent in your profits for the year, not your income, your profits.
I kind of get that in theory, but think about it. In my understanding, the engineering profession has been dealing with physical risk for a century. I mean, the term engineer started coming out of the railway system, and the engineers were operating the trains, and the number one job was don't collide on the track because back in the old days, most of the track was sort of single track. There wasn't the money to put two tracks up. It's still today. So, are engineers not all about managing physical risk, making sure stuff doesn't blow up, making sure there's not toxic discharges? I mean, in a lot of jurisdictions, engineering is a self-regulating profession because engineering designs impact public safety. Are cyber threats not seen as a threat to public safety?
Well, I agree with you that engineers know about risk and that's part of their discipline, but I don't quite fully agree that they're a self-regulating profession. A lot of this has been driven by engineering standards that have teeth and enforcement of local and government municipalities that drive that self-regulation. It's been an evolving process through the years. For every major fire or event, there's some government agency reviewing an event. Then you have that lawsuits and lawyers. You can't build a bridge without pulling permits and getting inspections. There is oversight. So I just had this broken sewer line repaired at my house. I mean, just take this simple example here. 10 by 10 foot trench was dug. You could say that my home sewer network was broken. But before the contractor could backfill that 10-foot hole, the local utility and code enforcement folks had to inspect and approve the work. The repair was actually just a simple plumbing job, replace some pipe. But digging and trenching were primary risks. So if a sudden rainstorm came through, or someone ran the dishwasher in a house, or worse yet, flushed the toilet, that would add to the risk. But I'm digressing here. If an asset owner has a broken network to a cyber event and I'm charged to get it repaired, who comes along to inspect the work I do? If the network is up, it must be properly configured, correct? That's not necessarily true. Where is the oversight in cyber? We have codes, IEEE, IEC, ANSI, NFPA. I can rattle them all off. And in the courses when I'm teaching the classes, sometimes we have these discussions as engineers, and everybody is knowledgeable in their field. But it seems like if I throw the word cyber in front of it, everyone starts screaming and running away from me. And so we've had a lot of security taken on in the industrial control system world since about 2010, in my estimation, because the regulations are being enforced in some sectors. But I still see the cyber as an aspect of business that the industry, we seem to be burying our heads in the sand, hoping that that next breach and headline isn't us. This is just my gut feeling.
From what you're saying, it sounds like the engineering profession, or engineers in the profession, they see cyber risk as somehow different from other risks they manage.
That's my perception that I'm seeing out there based on some of these conversations that I'm having. Now, things have improved, as I stated, but it's something I can't measure. It's just my gut feeling. There's been a lot of improvements. The vendors are pushing a lot of it because their customers want it, but it's cheaper just to make the same type of product. I don't have anything like in the United States. We have the Occupational Safe and Healthy Administration, OSHA, for cyber, where I can download statistics from. There isn't a clearinghouse for reporting any of these events. How do I prove a negative? If that cyber event didn't occur because of protections in place, that's good. But how do I create some type of tables, actuarial tables that I can look up to see when the next cyber-related event will impact my production? Out in the field, I hear comments such as, I didn't become an engineer to be a cybersecurity person. This cybersecurity stuff is fascinating, but I'm already juggling too many balls in my job. It's not that they don't want to do it, but it's just another add-on. Taking courses because they have to, or certs are required to increase pay and promotion, part of that progression that you may have set up formally, depending on the size of the company. You may be the engineer, the security person, the process control engineer, and the operator, all in one, playing different roles. So protecting the information isn't relevant to my mission. It's not my job. This is a statement that I've heard a few times now. I really like it. It's cybersecurity is the department of no. They impede my production and innovation.
What struck me in your comments there, the person who said, I don't see protecting the information as relevant to my job. Protecting information is IT's job. A lot of the sort of the early generation, the first generation of cybersecurity advice for industrial systems, I'm thinking, 62443-1-1, came out in 07. Wasn't even, I don't even think it was called 62443 back then. It was called SP99. But it talked about protecting the confidentiality, integrity, availability of information. Oh, wait, on industrial networks, the priorities are reversed. We're protecting the availability, the integrity, and then the confidentiality of information. And of course, nowadays, the modern standards really don't talk that much about protecting information. They point out that, look, the goal with industrial systems is to protect safe operations, to protect reliable operations. The goal is preventing consequences to physical operations. Information, isn't the goal. Is that part of the problem here? Are that, the at least the older standards and even some of the newer ones are just talking about the problem in a way that just doesn't speak engineering's language?
I can agree with that. I think you've hit the point well there. Just because we can do something doesn't necessarily mean that we should, as far as adding this industrial Internet of Things and IoTs and all that. An example here is I attended a Profinet training, try to shore up my skills there, and the topic of safety systems came up. And there's a number of safety systems that use Profibus. Now you can take that Profibus, you can put a TCP/IP wrapper around it, and voila, you have a routable protocol. Didn't really impact return on investment, ROI. But what have I done to the integrity of my safety system? Do I really need to monitor that safety system from my iPhone while I'm driving down the road or sitting in my sitting room? Does the CEO need to have that on his desktop via remote HMI, which I have seen? But no one seems to be asking, why should the safety system be accessible via a routable protocol, a TCP/IP stack, whatever you want to call it? Is it just because the vendor offers that solution, or everybody's doing it, so this is where we're going to go? But is there a mechanical fail-safe as a backup? Consequence-driven engineering, there's all these different terms. Yet we need to be looking at this from a process perspective. And then I was humbled to be sitting in with a bunch of engineers and code developers from Stellantis, Ford, GM, and there was even a ball bearing manufacturer there, and I don't remember their name. But he talked about just a little process upset, and they lose 10,000 precision ball bearings, which is millions of dollars of production, and they have non-conforming specs. So is that the ROI for cyber? We want to protect this, but now we've gone into, are we working on confidentiality, integrity, availability, or are we looking at the process itself and the consequence-driven engineering decisions that we're making? And I think that's there is a disconnect there.
So Nate, I asked Wally the question, is this a terminology problem? Talking about information rather than talking about physical safety. And I think his answer, he didn't say it in this many words, but what I heard was it seems to be deeper than that. The example he gave was engineers who just don't seem to be aware of the risk. Talking about tunneling safety systems straight out to the internet onto your cell phone, that introduces the possibility of hacking into those safety systems from the internet. But he qualified his answer. He said, it's more complicated than this is a dumb idea. He talked about CCE. We've had people on talking about consequence-driven cyber-informed engineering. We've had people talking about security PHA review. Both of these are methodologies that, as part of the methodology, include taking strong consideration of physical mitigations, an overpressure valve as opposed to a longer password on the PLC. If you have 2 or 3 or 4 of these physical mitigations in place for the safety considerations that the safety system, the safety instrumented system is supposed to be dealing with, you've already got, maybe 3 layers of sort of cyber-proof protection in place. And the safety system might be sort of the pièce de résistance, the fourth layer. And so it might not be as essential in that circumstance as it would be otherwise. And so, it's whether it's a really bad idea to tunnel your safety protocol out to the internet, in a sense, depends on the physical design of your process and whether, truly unacceptable cyber outcomes are even possible in that process.
Cyber attacks with physical consequences more than doubled in 2021. For industrial victims, the most common consequences were production outages at multiple sites. Most of the attacks were ransomware. And 2021 saw the first cloud-based ransomware attack. That attack compromised 1,500 businesses in the space of 45 minutes. These and other insights are included in a new threat report, co-authored by Waterfall Security Solutions and the new ICS Strive Industrial Incident Repository. For your copy of the report, please visit icsstrive.com. That's ICSSTRIVE.com.
You mentioned, mechanical fail-safes in addition to the digital safety systems that we're seeing. Can I ask you, in your experience, you get out in the field way more than I do. Are mechanical fail-safes, still being used? Are sort of mechanical systems still being used, or really how How far have we gone down the road of all digital safety systems?
Well, it's a surprise to me that we are going down that road more than I thought we were. Where we have that large red shutdown button you had in the data center or wherever in a facility, it was a mechanical switch you changed, or on a PLC, if you turned it to run or off, or non-programmable, that was actually a mechanical context that you were breaking. Now you're flipping a bit. It's connected to a circuit, and it's a bit in a processor that's accessible over the network. So if I can flip that logical bit, so can your adversary. And then the publicly disclosed attacks we don't always hear about, but the one back in December of 2017, there was this Middle Eastern oil and gas petrochemical facility. They went down for safety system shutdown as a result of a malware attack. Now, there's all kinds of stories about what was the adversary's intention. It probably doesn't matter if it was inadvertent or on purpose. But that malware, some of you be familiar with, Triton, Trisis, Hatman, has different names. It went beyond cyber attacks by directly interacting with a safety instrumented system. Those things are our last automated safety defense for industrial facilities. They're designed to prevent booms from happening from equipment failure, catastrophic incidents. So how much revenue and time can be lost because we've turned this into an electronic bit and there really isn't any mechanical backup switch?
Okay, so we've been talking about safety, but our topic is return on investment. Can we come back to costs? As you said, security costs money. Everything costs money, but safety costs money too. Do we have these kind of ROI issues with safety investments? And if not, why is security different from safety?
That's a good question. I think primarily what I see is that security still isn't part of the culture. We're getting there slowly, but it's not mandatory in most jurisdictions. Safety is. Safety has histories. You take a step back in time and look how long it took for safety to become part of the USA's culture, as I can speak to, but the other countries are involved too. Now, keeping in mind that I can manipulate statistics and make numbers do whatever I want, I think the following that I found is plausible. In the 2 years preceding our Occupational Safety and Health Administration Act here in the U.S., back in 1971, 14,000 workers died each year from workplace hazards. Then we had that chemical revolution following World War II, the Industrial Revolution, new chemicals, new manufacturing processes. The effects of the chemicals, the effects of the manufacturing processes, the potential dangers were not well understood. That was 50 years ago. Now, that has changed and progressed. We're losing too many people. That wasn't acceptable. We're still at about 5,000 reportable deaths in 2019. That's a high number, but it sure went down. Why? Why are the number of deaths down? Now, there's nothing absolute about that, but safety is part of that workplace culture. I worked out in the field. I traveled around. It was part of our compliance. It was paramount. We didn't think twice about it. We wore our PPE. We pulled permits to work in hazardous condition. I conduct tailgate meetings, design safety and hazardous processes in machinery. Do we still have tragic events? Unfortunately, yeah. Evidence here a few weeks ago, the two brothers killed in a refinery explosion. Was there a cyber component to that? I don't know. But the investigations will find that. But from a return on investment approach, safety has actually paid back because you can see what the lawsuits are, what the loss in production is. So we don't have that type of a measurement device that we do with security.
So, Nate, what surprised me in the answer there was 5,000 people died last year, according to OSHA, on the job. That seems like an awful lot of people. I'm not a safety guy. I'm surprised. So maybe it's not so surprising that the engineering profession is paying more attention to safety than it is to cyber. Last year we saw something like 100 plants go down in 22 different cyber incidents. Didn't see anybody, killed in at least, process and manufacturing industries. Gartner is an industry analyst on the IT space. They've also got a bunch of experts looking at the OT space. They're predicting that, and I'm reading from a headline here, that cyber attackers are going to weaponize operational technology environments to successfully harm or kill humans by 2025. They're talking about, by 2023, $50 billion in damages from, these incidents, litigation, insurance, regulatory fines. So, it looks like there's a big difference right now in terms of consequence between safety and cyber, but that consequence gap may close real soon now.
I understand it from an academic perspective as we're talking about it here, but it does feel a bit silly to be talking about like 5,000 deaths in an episode about ROI. Like, is there any amount of money that we can't throw at this problem to reduce the loss of human life?
Well, again, I'm not a safety expert, but the lay people often say, well, how can you put a dollar value on a human life? But businesses have no choice. They have to do this because nothing is ever perfectly safe. Even if you spend, a refinery spends $50 million every year on making things safe, there's still risk. And you could spend a second $50 million, bring the total to 100, and there would still be risk. You could spend another $100 million and there would still be risk. And so at some point you have to put a dollar value on human life. Business has no choice because you can't afford to spend an infinite amount of money to infinitely reduce the risk. So this is something that might seem alien to the lay people, but ROI and safety have to go together in these heavy industries.
Okay, so we've compared security to safety. Let's just look at physical security. I mean, are physical security ROI calculations not sort of the same, in a sense, the same as cybersecurity? I mean, if you're going to build a fence around your facility, that costs money. It costs money to pay every month. The guards standing at the gates. You need incident response teams. You need to practice those teams. You need liaisons with local law enforcement officers if someone cuts a hole in the fence and you need to report that. It's, in a sense, you need all the same stuff on the physical side as on the cyber side. Why is the ROI any different there?
Well, I don't think they're that different. They're very similar. A lot of the asset owners I work with, physical security is baked into the cost of doing business because they've been doing it for so long from the corporate side of the organization. It's just another thing that they have to handle, like HR, payroll, customer service, legal. Physical security is something that I can touch and feel. I can see, like crime prevention through environmental design, CEPTED. I can see the results of that, where I've moved vegetation, I've moved things around to make it easier to patrol, not allow a car just to crash into my lobby and things like that. I can see those things. But I do see a challenge with IT as well as the OT cyber, where the physical security folks, we don't collaborate as much as we should. It's always physical security, yeah, they're taking care of it, and IT, OT, checkbox mentality. Yeah, we got physical security, they got it, no need to dig into it. Because it's just around, it always has been. And the typical pen testing that I've done a few times in my career here, the open warehouse door, the outdoor break area, smoking dock, not picking on smokers, they're just right for walking in and collecting data or dropping off a stealth scan tool. It's almost, if most of the time, that's the easiest way to get in from a physical perspective. So they're always, it's kind of ironic that the tables are turned here. The cyber folks, we're focused on email phishing attempts, and the physical phishing attempts might be ignored by the cyber folks. So physical security has to take care of that and get the training in there. And there were a number of times where, I did get caught and there was good physical security in place. We don't hear a lot about these physical cyber related events, but recently there was a Department of Justice bulletin about a former operator at a Northern Ohio public utility. Now, he pleaded guilty to computer keyboard stroke capturing using utility key loggers. Now, yes, this was an insider threat event, but I would venture to guess this is happening more than we know by our adversaries. There's a lot of companies selling stealth technology devices on the internet. Who's buying this stuff? How are they staying in business? The nation states can develop their own devices. I think the key takeaway is physical security has a history now built in, baked in, just like safety has.
So we've talked a lot about the problem here. Can we talk about the solution? What's the way forward here, Wally?
Wow. If I knew the definitive answer, we'd be doing this interview podcast on a resort island somewhere and I'd be covering the costs. There's no one good answer. Now, regulations and fines seem to get asset owners' attention in the North American electric industry, especially since 2010 with the cyber portion. But as the regulators, stockholders, courts, legal, insurance companies, they're getting more cyber savvy. They're asking companies, what are you doing for cybersecurity? And insurance companies, before they provide it, a number of them are now requiring third-party approved vendors that they've approved to do cybersecurity assessments and services. This is what I'm seeing it and what's being relayed to me from my clients. The governments are pushing for elevated cyber maturity, but they even get pushback from their vendors. And then, of course, we bring out the snake oil sales companies that say, oh, we can demonstrate your compliance to the government, but it's going to cost you this much. And it's all on paper. Is it really more secure? And there's an unintended consequence when pushing more standards on small moms and pops, as I call them, the smaller industry. There's a lot of smaller industries, third-party providers that support industrial control systems. The nuclear electric generation industry in the United States here went through a phase where there was a mandate for increased security measures. That caused a number of the vendors to pull out of the market. There was no ROI for them on that, return on investment. It wasn't looked at by the authorities. We need to incentivize you and help you out here and see if we can pay a little bit more instead of the lowest bidder for everything. But cost versus operation by third-party vendors to support your system, what's the return on investment? It could put you out where you don't have suppliers. And then education, training, and accepting cyber as a cost of doing business will go a long way. We're slowly getting in that direction, more so than we ever did before. But from what I still see out in the field, I can tell you what it takes to become a master electrician. I know what courses, what certifications. If I want to be a professional engineer that can sign off on design drawings, I know what credentials I have to have. So what's the equivalent cybersecurity path? What is my oversight for cyber? Who's watching me? I have all these great certifications, but even I need some oversight other than the asset owner. So OT, cybersecurity, needs to have a seat at that corporate level. I don't see that a lot. If the large asset owners are ignoring the importance of cybersecurity or appear to be ignoring it, how can we expect everyone else to take it in a serious mode?
Maybe it's beside the point, Andrew, but the most surprising thing in what Wally said there to me was that there is such a thing as a mom and pop vendor in the industrial security space. I just assumed that the nature of this industry required vendors to be like at least medium or if not very large organizations.
Not at all. No, the industrial automation space is extremely fragmented, precisely because there's so many small and even medium-sized vendors. A lot of these small vendors are best of breed. They have a handful of engineers. They've studied one particular physical problem, intensely for a long time, and they have produced the best, physical automation solution that, that's then coupled to um, computer automation. Computers are part of all automation nowadays, but they've produced the very best way to, I don't know, tie tie shoelaces on the end of a shoe manufacturing line. Extremely specialized, best of breed stuff. I mean, I was talking to a gentleman who worked for a large consumer goods manufacturer. I said, what does one of your factories look like? He says it's a typical factory is 4 square blocks with 1,000 machines in it from 100 vendors. Some of the vendors have, dozens or tens of dozens of machines in the factory. Some of the vendors have 1 or 2 of their machines in the factory. There's a lot of small, extremely specialized vendors producing the very best of what they produce.
The other thing I thought to say here is that Wally's point about meeting with like regulatory compliance, I completely understand that, at least from an economic perspective, because the more rules and regulations you slap onto one niche of an industry or another, I imagine that large organizations have the resources to keep up, to hire the folks necessary to, and the technology necessary to meet those regulations. Whereas for the smaller vendors, the amount of work and investment that it might take to do that, relative to the budget that they're working with, and as you said, the small teams that they have available, is quite high.
Some of these vendors are still running their best of breed machines, computer automating them with Windows XP. Why? Well, it's because these machines have to be certified for safety. If something goes wrong in the machine and a technician has to reach into the machine to try and repair something or diagnose something, that machine had better not turn on while this person's arm or head is in the machine. They have to be certified for safety. And the computer automation is part of that certification. That certification costs something like, $250,000 to $500,000. If you're selling 10 of these machines a year, you could reasonably once expect to upgrade from, I don't know, Windows XP to Windows 10. But every little security update that comes out every month or two, you're selling 10 of these machines a year. You can't afford, 5 $500,000 certifications every year. You're not making that much money. So, it's a real problem. This is why in a lot of these industrial scenarios, we hear people talking about compensating measures. They're saying we can't upgrade these machines easily, so we have to protect them in other ways. We have to prevent the compromise from reaching the machine, because the machine is a soft target. They're not enough of them being produced to keep them up to date.
So if I heard you correctly, you said that greater regulation in some arenas, is part of the answer. I mean, you have to be careful with that it doesn't affect the small operators disproportionately. But there was new regulation that came out recently in the USA from the Transportation Security Administration for the nation's largest, only the largest pipeline operators. Can you speak to that? Is that sort of a step in the right direction?
Well, I'm trying not to pick up on the pipeline industry, but there's similar scenarios going on with government third-party mandates and all that in the United States. A checkbox mentality, get her done. We really don't have time or money to conduct all this stuff. It's going to impact our ROI. But we do have a good example here of where in 2021 there's an $8 billion company that was shut down due to ransomware. You can argue how it happened and all that, but at that time they didn't even have a cybersecurity manager on staff to lead whatever cybersecurity staff they had available that day, according to what I've read in articles that are publicly posted. They had posted a cybersecurity manager prior to that ransomware event, and they said it was for 30 days, but I've also read some articles where it was actually out there for a few months, and I didn't use the Wayback Machine to see if when those postings were out there, if they were caught. But the cybersecurity position there, what were they offering to pay? Why was it taking 2 months or even 1 month to fill that position? And it still wasn't filled. What bennies and what pay and what benefits? Was it an entry level type thing? I just came off of a cybersecurity conference here at home nearby with a few hundred people attending it. And one of the things that came up in one of the discussions is that our HRs are offering job positions for entry level cybersecurity, and they're requiring 8 years of experience, a CISSP, a master's degree with control system background, and it's entry level pay at $20 an hour. You're not going to find an entry level person with 8 years of experience. That's why they're entry level. So why did this large pipeline company wait? We've been tackling ICS cybersecurity challenges since 2000 when the ISA standards that you mentioned were being formed up. So this isn't like something new. And according to articles, this is an $8 billion company. I would conjecture that cost should not have been an issue. So what are we going to do about that? Well, here you go, knee-jerk reaction by the government, which maybe was necessary because shutting down a major pipeline is something very, very serious to the economy and safety and health and everything else. So now we have a new security directive for reporting confirmed potential cybersecurity incidents to the authorities. They have to do it now. They have to have a cybersecurity coordinator. Now, they don't say that they have to have a manager. Review all practices, identify gaps, report this to our Transportation Security Administration. But what I found interesting, there was no mention of costs or ROI. It was, you will do this. And for those of us who were around back in 2006, we had something very similar to this that's still actually on the books, the DHS Chemical Facility Anti-Terrorism Standards. There are about like 104 questions in there about cybersecurity, and it was mostly a checklist mentality, but nobody was following up and doing any oversight. And I don't know that ROI was a factor at the time. We got busy, life, business. We had this checklist mentality. Yep, we got security.
So that's a lot of information, Wally. I'm trying to figure out, are you saying that, CFATs and the recent TSA rules were a good thing or not?
I think from my perspective, with my auditing and regulatory background, they are a good thing with a good intent. But the programs are underfunded. I'm also seeing from my travels just here recently, working with some pipeline companies, that even TSA is having trouble finding qualified, experienced cybersecurity auditors to provide the oversight, because these cybersecurity auditors, they don't have an operations technology background, and they're pushing back on these companies and saying, how come you didn't put that patch in? How come you're still running that machine on Windows XP? You need to change that today, immediately. And of course, the pipeline operator pushes back and goes like, okay, so how many days do you think I should shut down and stop pumping oil? And who's going to approve that? But I do think overall, we can get the agencies in place that are in a collaborative type mode, not just with a hammer, to get this going. These regulations can go a far way.
Well, Wally, thank you for joining us and looking at some of these difficult questions. Before we let you go, is there a thought you'd like to sum up with? Is there a thought you'd like to leave with our listeners?
Yes. We've all heard that cybersecurity is a journey. It's not a destination that you reach and you're done. There's no such thing as 100% security, no matter how much money you throw at it. But OT cybersecurity, operations technology, we need a seat at the CEO executive level, whatever you want to call the position. It needs to be a board position. Job postings, as I've mentioned before, need to be more realistic. $15 per hour for a college graduate holding a CISSP is not really going to get you a lot of hires, and those fillings will stay open. But the cybersecurity challenge, this is a global issue. I have a global audience that I work with, and there are trainings that are available now that never existed before. like ISA has it and the DHS CISA. We got all of these acronyms and names, but there is a lot of specific quality training courses that are already paid for by the governments and taxpayers that are available at no extra cost. And there's colleges and universities. Have you engaged any of your colleges and universities in your local community? Get them to know, what cybersecurity skills do you need for your modern OT graduate that you want to hire? My final call to action, we have to be prepared to restore our systems from scratch and practice doing it for real. We have to have that engineering resilience built in. And when there's a fire or a natural disaster, there's usually a disaster recovery plan, business continuity plan, whatever you want to use the terms. It may have some dust and cobwebs, but it's usually tested at least a little bit. And we all have those. But we don't have anything like that for industrial control systems, an incident command system, in case of cyber events, roles defined, unless it's mandated like it is with some of the NERC CIPs and that. So what are the credentials required? And what training do I need to take to support cyber incident response in control systems? We do tabletop and paper drill exercises. They only go so far. When's the last time you restored one of your systems from scratch? Day 0, Greenfield. I was in the military, and the way you train is the way you fight. And that training must be realistic and perform to standard. We train as we fight must be more than just words. The same thing, we do our incident command system, our restorations with control systems must be more than just words. Thank you.
So, Andrew, that wasn't necessarily our cheeriest episode.
No. My biggest takeaway here was the thing that surprised me the most is the quotes that he gave from the engineers that he was talking to in the courses that he's teaching and the courses that he's taking. It sounds like there's quite the fair number of engineers out there that, at least in his experience, still think that cybersecurity is somebody else's problem. This surprises me because I thought this was the point of the engineering profession, to protect the public from different kinds of physical risks and cyber sabotage of industrial operations. A great deal of the time, it can put workers and the environment and the public at risk. So, that perception surprised me. Something else that shocked me was OSHA reported 5,000 deaths on the job last year. I thought that number would be much smaller. But again, I'm not a safety engineer. What I really hope is that it doesn't take thousands more serious industrial incidents before, the perception of the average engineer changes, perception as to their role in preventing deaths and disasters and other physical consequences of cyber sabotage. And, Wally talked a lot about the need for training and awareness and even regulations to sort of bring the engineering profession along. And what I especially liked was his point about there's no one size that fits all. I mean, sites with a lot of analog safeties in place are different from sites with only computerized safeties. And, really big sites tend to exhibit different risks than very small sites. And so, different kinds of cybersecurity programs are appropriate in each of these circumstances. The kinds that are appropriate are different from one circumstance to the other. And figuring all this out seems to be a gap out there that needs to be filled with training and awareness and guidance, I guess.
Mm-hmm. Then with that, thanks to Wally Magda for talking with us about this. And as always, Andrew, thank you for speaking with me.
It's always a pleasure, Nate. Thank you.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.